Is myself Shivsagar Amruta Ramesh from Sri Siddheshwar Women's College of Engineering, Solapur. Today I am going to explain the topic back EMF in DC motor with its characteristics of DC motor. So let's see what is back EMF. When motor armature rotates, conductor also rotates and hence it cuts flux produced by field windings. Hence, according to Faraday's law of electromagnetic induction, EMF is induced in them whose direction is found using Fleming's right hand rule. It is found that this induced EMF in armature is opposite to supply voltage, so it is called as back EMF or counter EMF. This back EMF is also called as counter EMF, and EB is the denoted word for the back EMF. That is, back EMF is denoted by the symbol EB, where EB is given means back EMF is given by phi p Zn upon 60A in volts, where we can see the equation for back EMF is here. EB is equals to phi Z Pn upon 60A volts, where flux in Weber Z is number of armature conductors, N is the speed in RPM rotation per minutes, P is number of poles, A is equal to number of parallel paths armature windings. Here we can see the diagram of back EMF generated in the armature. It will see that V minus EB is equals to IA RB, where IA is equals to net voltage upon resistance, that is I is equals to V minus EB upon RA, where V is equals to EB plus RA IB. From above equation, back EMF EB is directly proportional to speed N at standstill. EB is equals to 0. When EB is equals to 0, V is equals to IA RB. If speed is high, EB is large, hence armature current is small, that is, the EB is inversely proportional to the current. If speed is less, IB is less, hence armature current is large, where speed and EB back EMF are directly proportional and are inversely proportional to current. So EB acts like a governor, that is, it makes a motor self-regulating so that it draw as much current as it just necessary. Now let's have a look upon deriving the torque equation for DC motor. First of all, let's see what is meant by torque. Torque effect is a turning effect produced by the force is known as torque or moment. Torque is vector quantity, that is, it has both direction and magnitude. Torque is a measure of how much force acting on object causes that object to rotate, or sometimes referred to as moment of force. Also, torque is the force that causes an object to rotate around a fixed point or axis. In general, it is denoted by T is equals to F into R. Unit is Newton meter, where F is equals to force, R is equal to distance from the axis of rotation. When DC motor is supplied with a voltage, the current flows through armature conductor as well as through field winding. The field winding produces flux. In this flux, all armature conductors carrying current is kept. Hence, force is produced on armature conductor. The equal and opposite forces produces torque, due to which motor starts rotating. When V is equal to EB plus IARA, multiply this equation by V. multiplying the equation V is equals to EB plus IARA by IA, where V into IA is equals to IAEB plus IA square into RA. Name this equation as equation 1, where VAIA is equals to electrical power to armature, EBIA is equals to mechanical power developed in armature, and IA square into RA is equals to armature copper loss. The mechanical power developed in armature is also given by 2 pi nTA upon 60, where n is the speed in rotation per second, that is RPS, and equating both equations, that is EB into IA is equals to 2 pi nTA upon 60. That is why, because this both equation represents the mechanical power developed in the armature, so we'll equate these both equations. Hence the final equation TA is equals to 1 upon 2 pi into phi into Z into P upon A into IA. So by calculating the value of 1 upon 2 pi, we'll get torque, armature torque TA is equals to 0.159 into phi Z IA into P upon A. So this is the value of torque, armature torque. TA is equals to V is equals to PZ upon 2 pi A into phi into IA, when the value of 1 upon 2 pi is not calculated. But when we calculate the value of 1 upon 2 pi, we'll get the equation TA is equals to 0.159 into phi into Z into IA into P upon A. Here TA is the armature torque, or it is also called as gross torque. The TA, that is armature torque, is also called as gross torque. This is what all about the back EMF and torque equation for DC motor. Thank you.